Hi, welcome back to the series. I am Shoroff, MSc in Photogrammetry and Geoinformatics with practical experience in GIS, remote sensing, and geospatial data analysis. Let's start the video. Today we will understand what a shapefile is, which files belong to it, what it can store, and why modern GIS users sometimes choose another format. At the end of this lecture, you will see a short demonstration of what real-world shapefiles look like, including their attributes and specifications. A shapefile is a vector data format. It stores geographic features as coordinates together with descriptive attributes. For example, wells may be represented as points, roads as lines, and administrative boundaries as polygons. A single shapefile layer normally contains only one geometry type. It is called non-topological because it stores individual shapes without a built-in topology model for rules such as shared boundaries or network connectivity. The most important fact is that a shapefile is not only the .shp file. 3 files are required, and they must share the same base name. The SHP file stores the geometry. The SHX file is an index that locates each geometry record. The DBF file stores the attribute table. A PRJ file is optional according to the specification, but it is practically essential because it describes the coordinate reference system. When sharing the dataset, package all companion files together, usually in a zip file. Geometry and attributes are connected by record number. The first geometry in the SHP file corresponds to the first row in the DBF file. The second geometry corresponds to the second row, and so on. This one-to-one order must remain synchronized. GIS software manages this relationship automatically. Therefore, you should move, rename, copy, or delete the component files as one complete dataset rather than handling them separately. Shapefiles remain popular because almost every GIS application can read them, and they work well for exchanging simple vector data. However, the format was designed in the 1990s and has some important limitations. Field names are limited to 10 characters. Each component file has a 2 GB size limit. Null values, Unicode text, and datetime values are not handled as well as they are in modern databases. Shapefiles also cannot store topology, relationship classes, domains, or multiple layers in a single dataset. So, when should you use a shapefile? Use it when a client, authority, or legacy workflow specifically requests it, or when you need to exchange a simple vector layer with very broad compatibility. For a new QGIS project, GeoPackage is often a better default. It is an open OGC standard built on SQLite. It can store multiple vector layers and other content in one portable file, and it avoids many of the attribute limitations of shapefiles. The practical rule is simple. Understand shapefiles because you will encounter them everywhere, but choose a modern format when your workflow allows it. To summarize, a shapefile is a multi-file vector dataset. The SHP file stores geometry, the SHX file indexes it, the DBF file stores attributes, and the PRJ file usually defines the coordinate reference system. Keep all the files together, remember the format's limitations, and use GeoPackage when you need a more modern container. Now, let's move on to the shapefile demonstration. Here you can see the QGIS interface with an OpenStreetMap or OSM base map, which I have added as a web map service. I will now add several shapefiles from a simple land use database. First, I add the boundary polygon that defines the region of interest, or ROI. Then I gradually add the land cover polygons, road lines, building polygons, water bodies such as rivers, and public assets represented as points. Next, we can examine the shapefile's attribute table. Each row represents a geographic feature, while each column represents a specific attribute. The values may be similar or different depending on the real-world characteristics of each feature. Finally, we can view the shapefile's specifications by opening its layer properties. Here we can find general information, metadata, symbology, labels, and several other settings. If this video helped you, please like, subscribe, and share it. Thank you.